Hello and welcome to Project Management. This is a module for UG4 students in the Civil Engineering program at the University of Kurdistan. This lecture is being brought to you as a pre-recorded video because we are currently in quarantine with the coronavirus here in North Iraq. So some key information for this module. There will be 2 pre-recorded lectures every week, and this is the first one. And they're available on YouTube. If you're watching this, you were able to get there. A link to each lecture will be given on the Moodle page, and each lecture will be about 1 hour in length. Sometimes they'll be a bit shorter, sometimes a bit longer. And you can watch that whenever you want. Now, there is going to be a tutorial by Zoom every week. Again, there's an instruction manual on the university website about how to use Zoom, but I will send you a link on Moodle so that we can have meetings by Zoom, and it works a bit better than Skype. And this will be an opportunity for you to ask any questions. If there's anything in the lectures you didn't understand, we can go through that in the tutorial. So I'm hoping it will be student-led as much as possible. But that does mean you need to watch the lectures before the tutorial in Zoom. And that's going to be at 2:30 every Tuesday. We will do a test run of this beforehand, but yeah, plan that every 2:30 at Tuesday, that's when we will be having this Zoom tutorial. I will give you weekly readings that you will need to do, and this will all be on the required reading, the PDF book, which is on Moodle, Bendlador's Project Management. It's a 15 credit module. You're expected to do about 3 hours of study a week, as well as watching the lectures and participating in the tutorial. Now, a little bit of information about me. I have an open office policy. Now, as you know, my office is G3 and we're currently not at the university. However, I want to be as open office as possible and accessible to you. So I want you to know that you can contact me at any time between the hours of 8 a.m. to 4 p.m. any day of the week. I'm working full-time at home. I'm preparing lectures, I'm preparing assignments, I'm doing research. I am working. You can call me at any time. If there's anything at the lectures you do not understand, you can call me. You don't need to wait for the tutorial. If you can't, and my phone number is available on the module descriptor on Moodle. Now, you should all be logged on to Moodle now and enrolled, but if not, just remember Project Management is the name of the Moodle page. If you're not there already, please make sure you get on there. Ask me if you have a problem, but I gave the Moodle key before. And my email address is alan.collins@ukh.edu.krd. Now, assessment has changed somewhat. If you remember correctly, at the start of the semester, I told you that there would be a final exam, a midterm exam. There would be fortnightly assignments, and there would also be 2 projects. Now, we have to simplify things, quite frankly, because of this quarantine. So now there's going to be no projects, and there's also no midterm exams. In their place, there will be a 50% given to weekly assignments. They will number about 9 in total, and 50% for final exam. Now, I have to take attendance, if you believe it or not, and you need to be attending classes for 80% of the time. I have no idea if you're attending a class. The class is a pre-recorded video, for crying out loud. How do I know you're even watching this? So, if you hand in the assignment, I will count that as attendance, okay? So if you hand in the assignments, I will say that you attended the classes. Now, the final exam, I do hope that we will be back at the university in time for the final exam, and it will look much like final exams normally do. We will have it on the third floor. It'll be 3 hours, worth 50% of your grade. And the good thing is, handwritten notes will be allowed in the exam. No printed notes, no photocopied notes, but handwritten notes will be allowed in the exam. That should give you a real good clue that you need to be taking notes when you're listening to these lectures. Now, in the event that we are still in quarantine come the final exam, we will find a way to do the exam online using Moodle, but I don't want you to worry about that for now. I think in all likelihood we will be back at the university come July. Now, the key resources that I want you to be using is Oberlender's book, Project Management for Engineering and Construction. This is a fantastic book. It's the basis for how how I've written this course, and it's available as a PDF on the Moodle page, so you can access it through Moodle. Other books which are recommended reading and not required: Effective Project Management by Clements and Guido. Good book. I will say though that it's not directly associated with civil engineering. And then Panesh Selvam, Engineering Economics. Again, that's more about number crunching. We may or may not use that. But those two books in the middle and on the right, they are recommended books. They are additional resources. They're available in the library, but of course you can't get to the library right now, can you? I want to tell you that you don't need to worry too much about that. What you need to be doing is using the book on the left. If you want to read Clement's book and Panesh Selvam's book, you can get them on Kindle. I think they're about $20 each, but that is supplementary reading. It is not necessary. So what will we be covering in this course? Well, we're going to be talking about what is a civil engineering project and what is a project generally. We're going to talk about how projects begin and how you plan for them. We're going to talk about cost, namely how do we manage money, how do we budget for these projects, and how do we monitor expenditure. We'll talk about the opportunity cost of time. So opportunity cost is a term you should be very aware of from doing engineering economics. And we're going to talk about time management. There's no point building a building as cheaply as possible if it takes you 5 years to build rather than 1 year, because you're losing income you could be making from that building for 4 years. There's a big opportunity cost. So time management is very important. In the same way, quality management will be a key aspect of project management that we will look at. So project management is really managing the interface of cost, time, and quality more so than anything else. We will touch on risk management, and if we have time, and this is a big if, remember the new semester, it's only 10 weeks long in instruction time. We will cover health and safety and asset management, but those two parts will probably be dropped, just so you know. What this course will not cover is general management leadership skills. I think a lot of people have that idea when they think of project management, and that's just not what this course is about. We're talking about really the science of project management rather than the art of it, and how to be a good leader. You'll need to read a book on that, and I really think leadership skills can't be taught, they really need to be practiced. That's my personal opinion. Now, it also doesn't cover in-depth accounting. A lot of people think project management, they have an idea of spreadsheets and transaction analysis, and there won't be a lot of that. There's going to be no quantity surveying. We're going to have to use our calculators a little bit when we do budgeting. But the other thing is, it's not a specialized course in construction management. It's project management, not construction management. A lot of people confuse the two terms. But what happens in a civil engineering project? Well, there is investigations, feasibility studies, design work, testing of design work, construction, and then there's asset management. Construction is just one small part of an overall civil engineering project. And so we're not going to look at the specifics of construction management. There are courses you can do on that online and in master's level where you look at managing equipment and machinery. There's a bigger focus on health and safety and other things. That's not what this course is about. This course is not exhaustive either. It is absolutely impossible that I can teach you all aspects of project management in the next 10 weeks. That is impossible. Project management is a massive subject, and you could do a PhD on this and only be scratching the surface. So without further ado, I want to give you an introduction to civil engineering projects. So in this section, you will be learning about what is a project. You're also going to be learning specifically what are some of the key characteristics of a civil engineering project. We're also going to be looking at the influence of cost, time, and quality on a project scope. The word scope, we will get to that. That's about what the project is trying to achieve. And obviously, you can build something that is high quality, but it's going to affect the cost. It's also going to affect the time that it takes to deliver the project. You can build something quickly, but it's going to affect the cost, it's going to affect the time. Those three aspects of project management are crucial. They work against one another, but you need to balance them out in a way that the final user, the stakeholders, are pleased with the project. We're also going to talk about project life cycles. What are the basic milestones that bring a civil engineering project from beginning to end? We're going to talk about the role of a project manager. Who is a project manager? What does he or she do? We're going to talk also about project teams, all of the people who work on a project. And finally, we're going to look at some key differences between private civil engineering projects and public civil engineering projects. And from that, with a view to engineering economics, we will see why it is that most civil engineering projects are public works that the government or some government body pays for. I want to give you a few examples now of some key historical civil engineering projects. Now, the Hoover Dam was an absolutely massive dam when it was built. This is a famous dam. It's in Colorado, and it's from the 1930s. It's still there today. It's still operating, and it's still producing a huge amount of electricity, 2 gigawatts of power. That's enough electricity for all of Kurdistan from that one dam alone. To give you a little bit of perspective of how big this dam is, it is roughly 3 to 4 times the height of the Dukan Dam. It is absolutely massive. Now, this project commenced in 1922. That's when people first started talking about how will we find a solution to meet the energy needs for that part of the country. How are we going to provide electricity to those people? Now, look at this. It only began construction in 1931. So there were 9 years of initiating and planning and design work before construction even began. That might surprise you, but that's quite normal. And then construction only took 5 years. They built it in 5 years. Now, it cost $49 million, so about $750 million in today's money. There were 21,000 men who worked on the dam. There was a huge amount of population working there. They actually built a town called Ragtown where people lived while they were building the dam. And one of the sad things was that in that day and age they didn't have the best health and safety, and 144 people died in the construction of this dam. Now, the interesting thing about this dam is it was commissioned by the president, whose name was Hoover, and you might see that it employed a lot of people. The reason they built the dam the way they did was they wanted it to be low cost and slow. Time was not of the essence, and they wanted it to employ a lot of people. So they didn't use a lot of machinery when they built this. Why was that? Well, it was the 1930s. For those of you who know your history, you will know that that is the Great Depression. That was the time when there was a huge economic crisis all around the developed world. People were starving in Europe and in America. And interestingly and ironically, Iraq, that was its glory days. They call it Ayyam al-Uz. And Baghdad was considered the best city in the world. It was considered the Paris of the East. And if you were a rich person, you got on the Orient Express, which was a train that took you from Europe to Baghdad. And rich people used to spend their summers in Baghdad on the banks of the Euphrates. And the reason they did that was because there were restaurants, there were tea houses, and it was lovely. It was beautiful compared to Europe and America, which was going through an economic decline at that time. So President Hoover, in order to stimulate the economy and to create jobs, he said, let's build this dam that we've been talking about for many years, and we will build it in such a way that it will employ 20,000 plus people. So it was his way of creating jobs. They didn't actually need 2 gigawatts of power. They could have got by with a quarter of that, but they said, let's build it big, employ a lot of people, and then we can use the power in later life. Now look at this beautiful bridge. This is a little bit more modern than the Hoover Dam. This is the Millau Viaduct. It's in France. It's absolutely beautiful. I think it's quite possibly the most beautiful bridge in the world. I'd love to go there on a class field trip, wouldn't you? It's huge. It's 2.5 kilometers long. It's 270 meters high. It's absolutely colossal. Now, the project started in 1993. That's when they first had the idea of building a bridge across this valley. And construction began in 2001 and it finished in 2003. So this should give you an idea that construction is actually quite a small portion of the overall project. It cost $400 million to build. 600 people were employed in the construction. There was probably several thousand people employed in the planning, the execution, and the design of it. But look, it was built to last 120 years. The reason they wanted it to be this is a very high quality bridge, and that's why it was built very expensively, 400 million. They wanted it high quality, so it would last 120 plus years. And that's pretty typical for most civil engineering projects. You are going to need things to last a long time. They need to be high quality solutions. And I find this one of the joys of being a civil engineer is that whatever I design or build, there's a good likelihood it's going to live longer than me. It's going to remain there after I die. I can point to things to my grandkids and say, your granddad worked on that. Now, that's just a little pleasure that I have in civil engineering. Now, one of the reasons they built the bridge this way using a cable stay bridge was that they wanted the bridge to look beautiful. And by having a beautiful bridge, it's become a tourist attraction. 500,000 tourists go to this bridge every year. Isn't that incredible? And who can blame them? It's absolutely stunning. But by building a high quality bridge that was beautiful, they created an external benefit. There's another little word that you should know from engineering economics. The external benefit was the tourism industry. And so they built this bridge high quality because they saw external benefits to it if it was high quality. Now here's a civil engineering project very close to home. This is the Hamilton Road. So this is the road that goes from Gali Ali Beg to Choman. Now this project was built, the duration of the project was quite short. It was 4 years, 1928 to 1932. So they built this massively long road in a very short space of time, 4 years. It's quite a short space of time, really, especially in that era where they didn't have any machinery or anything. And the key engineer on this project was actually a New Zealander, Archibald Hamilton. So Archibald Hamilton, he actually has a statue of himself in Rwanda's, so you can see that in the bottom left-hand corner. That's me standing next to him, one New Zealander to another. And it's quite interesting for us because culturally in New Zealand we don't have statues. It's just not part of our culture. And so I find it quite funny that there's a statue of a New Zealander in the middle of Kurdistan, and a New Zealander who most New Zealanders know nothing about. He's more famous here than he is in New Zealand. But this was a very important road because it basically joined the Arabian Empire, the Ottoman Empire, and the Persian Empire together. So much of what makes Kurdistan great started with this road. Kurdistan became connected to a much wider part of the world. Before this road existed, really the Kurds were living in small villages. They had very often the villages didn't have any roads between them. They had no connection with the outside world. They were quite primitive in many ways. And the road was built for $10,000. He had very little money. This was just after World War One. There was also the Great Depression to worry about. There was no money, and he could only employ about 100 people. So there were a number of Kurds and also Indians who were employed in building this. And the way they did it was he would design 100 meters of road, they would build it, and he would design the next 100 meters of road, build the next. It was very piecewise how they did it. And apparently when they were building it, they kept being attacked by Kurdish bandits from Choman and the surrounding villages. These were wild, wild men who were very afraid of the outside world. And so it, this was a road that was built with minimal cost and minimal duration, very little time, and so that affected the quality to a degree. But nonetheless, this is a very high quality road in many ways, and the fact that the road is still operating, and it's been updated, and they've expanded it to 2 lanes and so on, and they've tar sealed it. But the fact that it's still operating as the key road between Iran and Kurdistan, the KRG, sorry, over 100 years later, or close to 100 years later, that is a testament to the very good workers who worked on this road. Let's look at a civil engineering project now that didn't go so well. This is the famous Leaning Tower of Pisa. And you may have noticed with the first 2 projects I showed you, they had a lot of time in the planning and the initiation of the project and in the design. Now, the guy who wanted the Pisa Tower, he wanted it really quickly. He wanted it within a year, I believe. And so they rushed the design. And one of the things which people do when they rush a design, one of the first corners they cut is they don't do a proper geological assessment. And they didn't have good technology for doing that back then. But anyway, they started building the tower completely unaware that on one side of the tower, the ground was very soft. And so they started building the tower, and when it was only 2 stories high, it already started leaning. What did they do? Well, you can't prop a building back up. They just kept building it from then on. And construction started in 1172. It's very old. And in 1178, they said, we just need to stop. It's leaning too much. And then it didn't start for another 60 years. 1233, they started, but then they immediately halted it again in 1284 because they ran out of money. And then they began construction for a 3rd time when they found a bit more money, and they started in 1319, and they finished it in 1372. This building took over 200 years to build, and it was a low-quality solution. Now, the good thing for the Leaning Tower of Pisa is it's now a tourist attraction. People probably wouldn't flock there from all over the world if it wasn't leaning. So, in the end, there was an external benefit to building a building that was leaning, but there wasn't at the time. This was meant to be part of a monastery, and they never used it for that purpose because it was too much of a lean. So until recently, there's been no benefit to this building. And I understand actually during World War II, there was talk about tearing it down because they didn't really see the value in it being a tourist attraction. Thank God they didn't, though. So with all of these projects, you should be seeing that a project, it's an enterprise that is carefully planned to achieve a particular aim. That's a general term for project. A civil engineering project, that particular aim will have to take into account many different stakeholders, including external stakeholders. Now, one of the key words with project is that it's temporary. It's a temporary endeavor undertaken to create a unique product, service, or result. This is very different to production management, project management. Production management, you're making one thing again and again and again. You're making thousands of the same project, of the same product, and you're trying to produce in an efficient manner. A product, you can't test the market and you can't correct mistakes. It's a one-time thing. You're not going to be able to build a house for a client, and if the house is no good, tear it down and start again. That will cost too much money. Another term for project is that it's referring to the people who deliver that resource, that product, that temporary product. So it will be a temporary organization of people and resources that is created for the purpose of delivering a one-off solution to an agreed problem defined by stakeholders. So we'll talk about that in time, but there are hundreds or thousands of stakeholders involved in any civil engineering project. So a project is time and cost constrained in its operation, and it's used to realize a defined scope at an acceptable quality. So with that definition, you have three terms there: time, cost, and quality, and these all have to be balanced out to the correct balance that keeps all of the stakeholders happy. And that's a very difficult thing to do. One stakeholder wants to spend wants more money spent and it to be higher quality. Another stakeholder wants it to be done quickly. Another stakeholder just says, just don't use my tax dollars too much. I don't care if it takes a long time or if it's low quality, just make sure it's cheap. And so you've got to find the correct balance. The literal meaning of a project, it comes from the Latin term, the coordination of creation. And I quite like that. How do you coordinate efforts to create something? Now, as I said before, project management is very different to production management. So think of a factory that is producing, producing bricks. That is production management. It's a repetition of a continuous line. If you make one bad brick, it doesn't matter. You learn from the mistake and you fix it. You can't do that with project management. It's a one-off thing. You build a bridge and it's worth $400 million. If it's a bad bridge, you can't tear it down and start it again. It's a one-off thing. Now, the scope can be easily revised and refined at ease with production management. So you're making a brick at a brick factory. It's a continuous line, and a client comes along. He's looking at the bricks and he says, actually, can you make these bricks a little bit smaller, a little bit lighter? Could you make them a different color? And you can just alter the production with ease, and you can change the inputs. You can't do that with project management. You can't look at the final solution and then say, I want to change it a bit. I need to revise it or refine it. You need to know exactly what it is you want and what all of the stakeholders want from the get-go. And so that's a really hard thing to define. And that's why with civil engineering projects, you spend a lot of time in the planning stage of a project, and that can take years. Now, with production management, teams are used to working with one another. That means you're part of a production line, you're working at a factory like a brick factory, and you've been doing the same thing day after day, week after week, month after month. You know your team members, and you work well together. Project management is a little bit different. It's a one-off project. You're building that one-off bridge, and so you have to get lots of specialists in for that bridge. You may have never worked on a bridge before, but you're a concrete specialist. There will be contractors you don't know. There will be earthquake engineers you don't know. There will be designers. There will be project managers. And because no two projects are ever the same, there are no two project teams that are ever the same. And so you need to learn to work well as a team, even with people you don't know very well and have only just met. That's one of the key things with project work and being a civil engineer specifically. You get to work with a wide variety of people, but those people will always be changing. Now, with production management, a mistake, it doesn't cost a lot of money. You make one bad brick, you throw that brick away, and you fix the error. Maybe you didn't have enough cement in your concrete mix, and then suddenly it's fixed for the next iteration. You can't do that with project management. As I said, you can't tear down the bridge or the building or the motorway and start again. And so with production management, you learn to become more efficient through practice. You start off very slow and inefficient in your production of bricks, but in time, with practice, you become more efficient. You can't do that with a project because you're only going to do this once. So to be efficient, that comes through careful planning. And as I said, you could spend on a typical civil engineering project, if it's a 10-year project, that could be 7 years of planning and then 3 years of design work and construction. That would be fairly typical for a lot of civil engineering projects. So these are two examples of project management versus production management. You've got their production management in the bottom right-hand corner, a factory making Coke bottles. If you make one bad Coke bottle, it's no big deal. You correct the error and then you carry on. No great cost. Also, the people working at that factory, they've been doing the same thing again and again for years. They know exactly what it is they need to do, so they can trust one another, and it works well. But if you were on a project, project management is very different. You're building something like a train station, and there will be no other train station like this in the world. There's no project that is ever the same as another project. Even if you're building two buildings that are identical, if you're building them in two different locations, the projects are very different. There's different ground conditions and geotechnical considerations to be made. And there will be hundreds of people working on this project for a train station, and you don't know half of them. You've only met them on this project. And so how do you do efficient work with project management? It's very careful planning, because you cannot go back and fix your mistakes. Well, you can, but it's very costly in terms of time, cost, and quality. So there are some different aspects of project management. So we're going to look at these in time. So scoping is something we do during the project initiation and the project planning. You are determining what are the set goals of the project. And to do that, you actually need to ask all of the stakeholders what it is they want. So if you're building a motorway and the government is paying for this motorway, you need to understand what the stakeholders want. Who are the stakeholders? Well, they're going to be people who live next to the motorway. They're going to be people who will be visiting Erbil, but mostly it's going to be people who will be using the motorway. That's going to be thousands upon thousands of people, and they will all have different requirements. One person wants the road to be to have an off-ramp at Ain Kawa. Someone else wants to make sure that there's enough U-turns so that if he makes a mistake he can turn around easily, and so on and so on. Other people want it to be cheap because they don't want a lot of the government's money going to the motorway because they don't use it very often. Other people want it to be high quality. Other people want it to be finished really quickly because They work on the other side of town and they want this motorway done tomorrow. And so you need to balance all of the stakeholders' dreams and desires, and you need to set constraints of cost, time, and quality. They all work against one another, but finding the right balance, which is the best solution. Following scoping, you have planning. Now, this is identifying, now that we know what it is that we want delivered, how do we deliver it? What are the steps and the tasks that need to be accomplished in order for this project to go ahead? And then estimating, that is identifying the resources needed to complete the project. Now, that's not just about cost, it's not just about money, it's also estimating the time to a degree, it's also estimating the people you need. Scheduling is about developing a timeline with milestones needed to complete the project. So, how can we complete this project in 3 years? How do we go about completing it in 3 years, let's say? And then organizing, that has to do with making sure that all the project team members, and they can be a lot. Just look at the Hoover Dam. 21,000 people worked on that. But even smaller projects, the Milau Bridge, there were 600 people employed just for construction. I can tell you that when I worked on a motorway project in New Zealand, there were 200 people in the project team. You have very big project team numbers normally with civil engineering projects, because civil engineering projects are big. You need to make sure that all team members, if you're the project manager, that they understand their roles and their responsibilities so that they are effective team members. And you're also organizing them to achieve the scope with acceptable cost, time, and quality. So, civil engineering projects can vary greatly. So I'm going to talk to you just briefly a little bit about typical civil engineering projects. So reverse engineering in the blue box in the top left. What's that? Let's say a bridge fails. There's an earthquake and a bridge falls down and someone dies. The government will launch an inquiry. What will they do? They will actually ask an engineer to go to site, and they will say, "Can you tell us what made that bridge fail?" And the engineer will do what's called forensic engineering. Do you know what a forensic pathologist does, or forensic coroner does? You've probably seen that on the police shows on TV. That's where they look at a dead body and they determine how did this person die. And they say, well, he died from a stab wound, or he died from hanging. It's the same with engineering. The engineer looks at how the bridge failed and he says, this bridge failed because there was not enough cement in the concrete. This bridge failed because it wasn't designed with enough reinforcement, or it failed because he didn't follow the earthquake code. And following that, governments will then sue and imprison whoever's responsible for the engineering failure. A design project, that's quite clear. That's where you're paying an engineer to design a piece of infrastructure. Engineering standards review. You've seen a few engineering standards when you've seen things like concrete technology and building materials. We saw standards in there. These are basically the general guidelines that other engineers have followed when they have built similar projects. So there's standards for what to consider for your earthquake acceleration when building a house or a building in Erbil, for example. There's standards for the kind of concrete you can use, what kind of aggregate you can use in a concrete, and so forth. There's thousands of standards. Those standards were written by engineers for engineers. So an engineering standards review would be where a group of engineers or an engineering body such as the Civil Engineering Institute of the UK, they will pay an engineer or an engineering company to review the engineering standards to see if they need to be updated or changed. Construction project, that's when you've finished the design work and now you're building. Now, an audit. What's an audit? Well, an audit is basically a third-party review. Let's say I want to build a dam. I'm a government official and I'm looking to build a dam on the Lesser Zab River. And I hire Avan to design this dam. And then Avan goes away and 6 months later she presents me with drawings of this dam. Is it a good design? Is it a good report? Is it a good dam that she's giving me? I have no idea. What would I know? I'm a politician. I know nothing about dams. What do I need to do is I need to hire another engineer, usually someone who's not friends with Avan, and they need to check the design. So I could go to Yar. Sorry, I know that Avan and Yar, I know you're friends, but for this example, let's say you're not friends. And Yar will edit and review Avan's design work. And usually people are very honest and open. They will not look for problems that aren't there. So Yara could come back and say, this is a good report. I would change the design a little bit here or a little bit here for this reason or that reason. But that's an audit. The next part is a feasibility study. So a feasibility study is where you're looking into the potential for a solution. So this is often part of an options report, and we'll get to that in a due course. But let's say with that dam, I'm thinking of building a dam on the Lesser Zab River, but I need to consider if it's feasible. I need to look to see if the cost to build such a dam, if the time to build it, and if the quality is acceptable, is that even possible? And is it economically justifiable? Do the benefits of it, including external benefits, outweigh the cost, the external costs as well? So another word for a feasibility study is a cost-benefit analysis. And so it's usually engineers doing this rather than economists. And that's why you need to know a certain amount about economics if you're going to be a civil engineer. An environmental impact report is looking at the cost to the environment. So if we build this dam on the Lesser Zab River, it's going to create a big lake and it's going to flood land. What's going to happen? A lot of the wildlife could die, a lot of endangered plants or animals could die. What if it floods habitat for the leopard, which is a very rare creature now in Kurdistan? We need to consider that. Why? Because we need to know what is the external cost in terms of the environment. That is part of any decent feasibility study. Now, an inquiry report is similar to reverse engineering. Reverse engineering is usually part of an inquiry report, but I really hope you never are part of this. They're on the wrong end of an inquiry. This is not a nice thing that happens. When a civil engineering project is a disaster, meaning the infrastructure breaks, or it cost a lot more to build than you budgeted for, or it took much longer to build than you had scheduled for. Sometimes there will be an inquiry, and that will mean that the stakeholders will get together and they'll say, we need to learn what went wrong so that we don't keep repeating this. So a very famous inquiry was called the Fraser Report, and this was an inquiry into the Scottish Parliament building. It was built in the late 90s, and it was built for hundreds of millions of dollars, and it's a very small building. It's not much bigger than the Parliament building in Kurdistan. It shouldn't have cost $100 million. And who had to pay for that? The taxpayers. So everyone was furious, and there was pressure on the government. So the government said, we need to launch an inquiry to find out why it costs so much. And a lot of that came down to bad project management. And so civil engineers were involved in that inquiry report because they're saying, well, this was over-designed. You didn't need to build the ceiling out of gold. You didn't need to build the windows out of diamond, and so forth. That's an inquiry report. Now, an options report, a feasibility study is usually part of an options report. This is where you're looking at different options. Let's say we have a problem in Kurdistan, which is we don't have enough electricity for what people are demanding. Now, that's very easy to understand because that's the reality in Kurdistan. Let's say the Ministry of Electricity says we need to generate more electricity and we've got the money to do it. How are we going to do it? An options report is looking at the potential and the feasibility of different options. So one thing could be a new dam on the Zab River, or it could be generating solar energy on the Nineveh Plains, or it could be generating wind energy in Chan Chamal. The options report would carry out a feasibility study on all of those different options and basically weigh out the costs and benefits of each so that you can make an informed decision as to which option to go with. Asset maintenance planning. This is something that I actually did a lot of when I was a professional engineer. I did a little bit of design work, but I spent most of my professional engineering career in asset management or asset maintenance planning. In this case, you're not designing, you're not constructing civil engineering infrastructure. The civil engineering infrastructure is already built. What you're doing as a civil engineer is you're assessing it on an ongoing basis and you're looking at what needs to be done to maintain the civil engineering infrastructure. So everything decays, nothing lasts forever except the grace of God. And so with anything we build, we will need maintenance. Even concrete needs maintenance. And so that's what I did. I was actually an assets manager for dams in New Zealand and then in later life Oman. The final example of a civil engineering project is stakeholder advocacy. So let me give you an example of stakeholder advocacy. Remember that with any sort of civil engineering project, there is going to be hundreds, if not thousands, of different stakeholders. And it's very important that the project manager and the project sponsor, the person paying for the project, considers all of the stakeholders. Now, let's say the government wants to build a dam on the Greater Zab River. Or the Lesser Zab River, let's say. They've done the options report and they say the best way to make more electricity for Kurdistan is to build this dam. But it's going to create a big lake, which is going to flood everyone in Barzan. Now, what those people in Barzan, they may say we're being overlooked here. And so they may actually hire an engineer to argue their case, to say, look, if you build this dam, look, you're going to flood these people, and then that's a very big external cost. And then they will either alter the dam or they will pay to have those villagers moved. Now, that is actually a fairly common thing, if you can believe it. Often, when people design dams, they do not consider what is flooding behind the dam once they create the lake. If you can think of, I don't know the name of the lake, but the lake the dam that was recently built, if you drive to Slimani, you go over this dam. When they built that dam, they did not consider the land that would be flooded behind it, and it actually flooded the road. So stakeholder advocacy gives stakeholders an opportunity to make sure that their view is heard, and they will often hire civil engineers for doing that. So an example is actually Greenpeace or other environmental bodies will often hire civil engineers to do environmental impact reports. So that's an example of a few different kinds of civil engineering projects, and they may interact with one another, but those are the sorts of projects you could be involved in as a civil engineer. But what I need you to understand from this lecture is that whatever you do with a project, whatever the scope of the project is, whatever the goals are that you're trying to achieve, that you need to balance out cost in terms of money, time, and quality. And they affect one another. If you build it high quality, it's going to take longer and be more costly. If you build it cheap, it's going to take longer to build and be lower quality. If you build it in a short amount of time, it's going to be more costly and lower quality. And they all interact with one another. It's very important that in defining the project scope, you are building the project in a way and you are designing the project infrastructure in such a way that it has acceptable cost, time, and quality constraints. That is what project management is about, balancing these three sectors. And that's why this is called the project management triad.